Welcome to the online session on smart and sustainable buildings and cities. So our first presenter is Dr. Jeremy Gibberd from the Council for Scientific and Industrial Research all the way from South Africa. And the title of his paper is Integrating the SDGs into Green and Sustainable Building Rating Tools. Over to you, Jeremy.
Hello, my name is Jeremy Gibberd, and I'm going to be presenting a paper called Integrating the Sustainable Development Goals into Green and Sustainable Building Rating Tools. As background to the paper, it's important to think about some of the kind of global issues. So the global issues are achieving the Sustainable Development Goals and also some of the climate change carbon emission targets. And if we look at the Sustainable Development Goals, it's clear that many countries are not going to achieve the Sustainable Development Goals. We can also look at construction and the building industry. And again, it's clear that the Sustainable Development Goals haven't really been addressed. So we need to ask whether there's more that we should be doing. We can then look at some of the detailed guidance tools, the rating tools, so things like green building tools, and ask whether these address the SDGs. And if they don't, what are the gaps and what are the improvements and recommendations that can be made? So the structure of the presentation is firstly a quick introduction to the Sustainable Development Goals. Secondly, an aspect of the paper was an analysis of the SDGs to look at implications for buildings. Thirdly, we select two tools, the Code for Sustainable Homes and the Sustainable Building Assessment Tool, and introduce those and then evaluate their criteria in terms of support for the SDGs. And then finally, the conclusions and recommendations. So firstly, the Sustainable Development Goals are 17 goals that have been agreed on by most countries and have been developed by the UN and are being tracked by the UN. And there's some very nice websites that you can use to look at progress. And this particular dashboard is for South Africa, and it shows that progress in many cases isn't fast enough. Many of the squares are red or orange. Many of the arrows are horizontal, they're not pointing upwards. And it shows that much needs to be done in terms of achieving the Sustainable Development Goals. And one of the key things that have made this much worse in the last 2 or 3 years is COVID. So this particular graph shows how there's been very good progress in terms of reducing levels of poverty in the last 5 or 6 years. And then around 2019, as a result of COVID, there's been a huge spike upwards in terms of these blue lines, which show that a lot of the progress that have been made really over the last 2 or 3 years is likely to be reversed. What is also interesting is to look at the IPCC reports, the International Panel on Climate Change, and this particular graph picture is from a report from 2018. And what it is interesting for is the change in approach that it shows. So firstly, very clearly, we have to move away from business as usual, which is totally unsustainable. We had moved to a stage where we were looking at incremental change, particularly technological change in terms of carbon emissions, so better light bulbs, better heat pumps, etc. And really we are now moving to a stage where we can't just look at lower emissions. We actually need to look at achieving the SDGs. And this is a much more transformative approach, and this is really being advocated by organizations like the IPCC. So one of the first things we do in the paper is look at the implications of the SDGs for buildings. And we take each of the SDGs and unpack that and extrapolate the implications. And there's quite a nice table in the paper that shows those implications. So the first tool that we look at is the Code for Sustainable Homes. This is developed by the Building Research Establishment in the UK, very widely used for homes, and it measures performance of housing, of homes, in terms of energy and CO2 emissions, water, materials, surface water runoff, waste, pollution, health and well-being, management, and ecology. So underneath each of those headings, a set of sub-criteria that are used to measure the performance of housing. The second tool that we look at is called the Sustainable Building Assessment Tool. This was developed in South Africa and uses quite a wide range of criteria to measure performance, including energy, water, waste, materials, biodiversity, transport, resource use, management, products and services, local economy, access, health, education, inclusion, and social cohesion. So one of the first tasks we do is to take each of the tools, look at the detailed criteria in terms of the Sustainable Development Goals, and then present the results as a matrix. And so the first matrix shows the results for the Code for Sustainable Homes. And what this shows is it shows that there's direct support for the following SDGs: 3, health, 6, water and sanitation, 7, energy, 11, sustainable settlements, 13, climate change, 15, sustainable ecosystems. We do the same for the Sustainable Building Assessment Tool, and what you can see here again is the matrix that shows the results. And what this shows is it shows the SBAT provides direct support for food security, health, education, water and sanitation, energy, sustainable economic growth, sustainable industrialization, reducing inequality, sustainable settlements, sustainable consumption and production, and climate change and sustainable ecosystems. What we then do is pull those results into a summary table with the first column showing all the SDGs, the second column showing the results for sustainable homes, and the third column showing the results for the Sustainable Building Assessment Tool. And what this shows is that there's very clear direct support for 6 SDGs in the Code for Sustainable Homes and direct support for 12 SDGs in the Sustainable Building Assessment Tool. So to come to the conclusions and recommendations, firstly, both the tools support SDGs 3, 6, 7, 11, 13, and 15. The Code for Sustainable Homes does not directly support other SDGs, whereas the Sustainable Building Assessment does support education, economic growth and employment, and reducing inequality and sustainable consumption production. Neither of the tools address SDGs 5, 14, 16, and 17. So to come to the recommendations, really the study makes the case that new tools, the next generation of green and sustainable building assessment tools, should be more aligned to the SDGs and support SDGs better. It suggests that there are criteria in the SBAT, the Sustainable Building Assessment tool, that are relevant. So things like local economy, resource use, education, inclusion, that may be useful to look at in terms of those new criteria. Thank you very much. If there are any questions or interest in finding out more, please feel free to get in touch.
It was really interesting. Any questions from anyone here or online questions? No questions. Okay, there's one from Pauline. To what level is SDGs being implemented in South Africa at the moment? Jeremy?
Okay, thank you. Yes, it's very interesting. So I think the slide to look at is one of the early ones, which actually show that performance is actually going backwards in a couple of areas, unfortunately. So if you remember the two pictures, the bottom one is an earlier year and the top one is a later year. So we're declining in a number of areas. And I think because of COVID, that actually is happening in many countries. I think South Africa is not the only one where the SDGs are increasingly unlikely to be met. I think that's a pattern common to certainly many developing countries, but even some of the developed countries. Thank you.
The questions? Okay. Next presenter is Harsha Muthumala, and the paper is titled Energy as a Service, a new business model for the built environment. Very interesting topic, so we give over to you. Thank you very much.
Good afternoon, everyone. So in this session, I will be presenting my paper under the topic of Energy as a Service, a new business model for the built environment. I'm Harsha Muthumala from RMIT University. So as you may have already aware or even witnessed, especially during recent tension around energy prices, the entire energy landscape in Australia is under pressure. So this energy transition that we all are concerned about at the moment has become a major concern for built environment as well due to its increased carbon emissions. And these sectors are now really focused on sustainable and innovative ways to source their energy than from traditional utility supply. So this has created an opportunity for new business models or new entrants to enter into energy markets to propose, capture, and deliver value to customers who are interested in more decentralized renewable energy sources or services. And since these new business models are challenging the existing energy system to a more complex transactive model, literature suggests exploring business models. And under this research, it focuses on one particular business model called energy as a service. So energy as a service has started to get an increasing attention in industries and recently from research community as well. And it has been defined by various definitions as a business model that offers various energy solutions to balance between customer demand and supply. And market reports explain that uh, Australian energy as a service market is in early stages. And this is also an indication to lack of previous research or peer-reviewed literature available on energy as a service business model. So this literature gap about energy as a service is set to address the problem under this paper as what type of energy as a service are present in the built environment energy transition. And in addressing this problem, the study relied on the findings of 29 semi-structured interviews conducted with service providers and customers related to built environment, with questions like how do you see energy as a service market and what solutions or activities do you see in the energy as a service. And thematic analysis was used to identify and develop energy as a service types. So, as I have explained before, the study seeks to identify types of energy as a service. And in doing that, I have relied on three components of business model from the literature, such as value proposition, which means the benefits offered by the business model, and value capture, which is the revenue and cost structure of the business model, and lastly, value delivery, which is the activities and resources used to execute business model. And findings on different energy as a service applications or examples that interviewees mentioned was used as the basis to classify and develop energy as a service types. And accordingly, four types of energy as a service were synthesized as shown in this table. And with their characteristics, they were named as GES, FP, GO, and PF. So next set of slides, I'll explain these types in detail. And in doing that, I have added a diagram to explain the structure of the type and a sample quote for each sub-theme that guided me to develop these types. Right, so coming back to type 1 of energy as a service, green energy supplier. As shown in this slide, the green energy supplier or GES is a solution that provides energy supply with green decentralized energy sources. GES is similar to traditional utility supply and bills based on kilowatt-hour unit consumption, but with a focus on renewables. A common GES example was solar power purchase agreements, and common value proposition for GES is that there is access to renewable energy and also reduction in energy cost. A revenue and cost model under GES includes service payments consisting with capital and operational charges. And in executing GES, a potential opportunity is identified with existing energy consumption data via sales and marketing team. And other activities involved analysis of different consumption scenarios and executing service contracts. So for this, strategic customer and supply relationships was found as important in value delivery of GES. So second, energy as a service type, functionality provider or FP is a solution that involves service provider offering functionality of energy assets as a service to deliver energy outcomes such as efficiency or warmth. And this was found to be a less common market in Australia than GES. However, a little demand in commercial and also in some parts of residential market was found with value propositions of differing capital expenditure and accessing to energy efficient systems. Common applications of FP are energy service agreements, lighting as a service, cooling or heating as a service. And similar to GES, these FP applications also follows a similar revenue and cost model with monthly service payments. However, this promotes energy savings, in other words, negative energy as a service, and that covers a wider scope than GES. So service bundling was a common feature in FP type, and similar to GEF, FP execution was also relied on sales and marketing to reach and identify potential customers. In FP type, establishing functionality levels considered the energy consumption profile and characteristics of the building. And development of this type is dependent on high energy prices and lower financial rates for service providers. So the third energy as a service type, grid optimizer or GO, as shown in this diagram, features displacing energy from one market segment, such as residential or commercial building, as vendors, and offering the reduction of energy flexibility as a service to another customer segment, such as a system operators. And geo value proposition included increased renewable energy adoption and modified energy generation for grid stability as well. A common application of this type is virtual power plants, where geo acts as a messenger between generation and customers. And in revenue and cost model, uh, customers as vendors benefit from direct payments from GO for flexibility offered, while the service provider captures the value with payments from system operator. And in executing this type, Geo examines the customer potential to provide flexibility depending on the customer's availability. Therefore, communication between vendors and customers is important in Geo value delivery. And also, advanced IT resources are used to aggregate flexibility resources in this type. The fourth and final energy as a service type is a solution that involves energy sharing between prosumers. So the main market that's unlocked here is between customers who can more cost effectively trade power than their utility. And value proposition under PF promotes renewable energy consumption, economic benefits to prosumers over bill credits. So common application of PF includes peer-to-peer energy trading software and control processes. So these are normally backed with Internet of Things and blockchain technology. And revenue and cost model on the PF includes aggregating different energy customers and operating the platform, where users need to pay a license fee to get access and services on the platform. In executing this type, sellers list excess energy and also potential buyers search to buy energy from it. So electrical connection between customers or different users is maintained by distribution network. So for these software and IT capabilities were found as important for this type. So in concluding, this study investigates about types of energy as a service, particularly under energy demand side, taking built environment as the scope. And out of which 4 types identified offers service providers to configure different value propositions. For example, energy assets installation versus energy flexibility, and different financial models in value capture. For example, performance or fixed monthly base service payments, and different value delivery options. For example, client side versus supplier side. Therefore, although they are presented as 4 different types, given market conditions of decarbonization, decentralization, and digitalization, these 4 types are already to some extent converged together and might become even more converged in the future. And what that would essentially mean is that this energy as a service type helps to transition from a system of distinctive components of energy suppliers, distributors, and customers to a group of players involved in energy transport, intermediaries, and energy resources. That concludes my presentation. Thanks for listening.
so much. Any questions from anyone online? Okay, thank you so much. I think it's a really relevant issue, especially also in terms of the SDGs and responsible consumption and production. I see there is a question. How would this be in for energy figures with the AEMO platform in Australia? Harsha, are you there? Harsha, if you could just unmute, we can't hear you. We're just trying to make you a presenter. One moment. Okay, Harsha, seems that...
Yes. Sorry, can you hear me?
We can hear you, yes.
Thank you. Thank you for your question. I just want a bit of clarification. When you say figures with the AEMO platform, does that mean the wholesale prices, or what figures are you talking about?
Can it be integrated?
Yeah, so I'll answer the question in the way that I've understood the question. So the study that I have done is from a property sector perspective. So the platform, I'm guessing that you were talking about the platform facilitator type. So what I have investigated is from the property sector. It's basically an advanced version of a peer-to-peer energy trading, or rather blockchain technologies that we are sort of using at the moment. So in terms of using it as a market platform, or maybe in a different wholesale level, this study had not investigated at that level, but what it has investigated is from a property sector perspective, where service providers to property sector, retailers, or from the other side, prosumers, how they have integrated a blockchain, or rather energy sharing opportunities as energy service, energy as a service is being investigated. I hope that answered the question, if the way that I've understood.
Really appreciate it. Okay, the last speaker of this session is Pauline, also from the RMIT University, School of Property Construction and Project Management. And the title of the paper is The Social and Environmental Impact of Building Integrated Photovoltaics Technology. Thank you, Pauline.
Thank you, Karen. Thank you, everyone. My name is Pauline. I'm a lecturer at RMIT, and I'm presenting on behalf of the co-authors, Dr. Sajani and Sotirios. And our paper is The Social and Environmental Impact of Building Integrated Photovoltaics Technology. Yes, just a bit about the authors. Sotirios is the first author of the paper. He's a graduate of RMIT and it came out of his final year honors thesis. So he's very happy for this paper, but he's not able to join us today. And so I'm presenting on his behalf. Okay, so just about what is BIPV. BIPV is an emerging technology. It is a type of photovoltaic system which is integrated into the building envelope. Okay, so it's either mainly within the building facade. It has achieved substantial growth over the past few years globally, and it has a very fantastic economic and cost and benefits for BIPV. The researchers have gone into mainly focusing on the economic benefits of BIPV and the energy payback time in majority of the cases were recovered after a few years of operation. So the beauty of BIPV is that it can be considered as part of the building construction. So you don't need to have a separate line for a separate item for sustainable features, but you can have one item in the construction cost as part of the building facade, and that is the beauty of that. Plus, it generates enough energy and helps to bring in cost for profit for the building. So despite that it's being a very promising technology with a very attractive energy economic performance, the uptake of this technology is rather limited. Globally, it is promising, it's growing, but within Australia, you can see that the uptake of the technology is limited. Mainly because it's still an emerging technology, and for example, developers in large-scale construction projects are a bit uncertain about the value added that this BIPV system can offer to the project. So the researchers view that any kind of renewable energy project is really highly dependent on the social acceptance of the project. So we find that in the literature, Sotirios, you found that there is a lack of research on the societal costs and benefits of the BIPV technology. We feel that through exploration of how BIPVs can affect the different social aspects within the society, it can help improve on the adoption of the technology. Therefore, next slide, please. Yeah, the study aims to identify the societal cost and benefits of BIPV technology and also to identify the factors that affect its adoption. So most of the studies that Sotirios had found was that it's more geared towards the economics side of things. And if we can delve deeper into the societal costs and benefits, it can help with understanding why there's this lack of acceptance. The uptake of the technology. So Sotirios had conducted a literature review using a systematic approach using this keyword search on the RMIT University Library. And he has set all the parameters. And in total, he could find 45 articles that he had was able to identify and to review them. So he's conducted a thematic analysis by trying to identify common themes within the literature, categorizing the literature into different themes, and he had done this process manually through NVivo. So he used a few techniques of descriptive coding, topic coding, and analytical coding. So and trying to figure out what are the main themes for BIPV uptake. So in total, he assigned them into 4 themes, such as environment, health, design, and social. And in total, 19 factors were identified. So he's come up with this diagram where the 3 themes, when they interact, is the social theme. So the costs and benefits of the 4 themes that were reviewed were the first one is the impacts of environmental elements. The second one is the design context in the built environment. The third one is effects on user health and well-being. And the last one is the influence of social behavior at a community level. So all this will lead to a social impact in terms of the societal acceptance of the BIPV. So he's gone through the literature and sifted through the literature and consolidated into 19 factors, and which are then categorized into the 4 themes as shown here and into costs and benefits. Okay, so he's got the first one is environment. In terms of environment benefits, the obvious one was land conservation. As the BIPV components are being integrated into the building envelope, it does not require additional land area or building area for installation because it's part of the building. So as opposed to large solar farms where you need a lot of land for that, we can just use the existing building. You can also install BIPV systems on deteriorated building as part of the refurbishment project, and you can just install them on the outer skin of the structure. This can be an effective way of incorporating renewable energy to existing buildings without needing to use any build-up areas already that we need to use build-up areas. So it helps to in terms of trying to save some space for renewable energy. So so some of the benefits, but in terms of the costs, the only cost with the BIPV is that there will be some pollutants that will be emitted. There will be some pollutants being emitted during the production of the system that needs to be treated before being released into the atmosphere. But overall, the cost of production can be offset by the energy that's being generated and also through the CO2 emission, reduction in CO2 emission. So, and that's one of the key benefit. In terms of health and well-being, how does BIPV help is with that BIPV systems can be integrated with sun shading devices to help to assist with natural lighting. So, and it also comes in various different thermal properties, and also it can be semi-transparent glazing. So it helps with visual comfort and reducing glare. There's also you can have outdoor views, and so it's important for the satisfaction of the occupants of the building, especially in commercial buildings. Yeah, so it has some benefits in terms of the well-being of the occupants. The negative of that is the negative is that could be associated with BIPV is that there can be psychological stress amongst the users, the owners who may have anxiety about whether the system works, whether concerns of the warranty period and things like that. So, but I would say when comparison with the benefits clearly outweighs the cost. In terms of the design theme, aesthetics is a key component, a key benefit. So the ability of BIPV to offer enhanced aesthetical appearance to building design is one of its major key benefits because it has options for colored modules. The installation of BIPV glazing can give a building a unique architectural appearance or characteristics, giving it an aesthetic advantage over the others, like for example, BIPV, for example. But the only the cost of it would be the complexities of or the lack of awareness as such of the stakeholders with the system requirements, the requirements for the BIPV system in terms of the design. It can be considered as a challenge, so it can be acting as a barrier in terms of the design theme. So the architects, engineers may struggle to coordinate this interface with standard building elements because of the unfamiliarity, which may lead to the barrier of adopting the BIPV system. So yeah, and there could be issues with the older regulations and building codes that that was found in the literature to have restricted the installation of BIPV products and preventing the adoption of the technology. And the last one is the social impacts of BIPV would be, the benefits will be employment opportunities, employment generation, public awareness, social status, and a positive attitude towards green renewable energy. So these are the benefits. So the public awareness will be related to the acceptance of BIPV in the local community or within the city or the project. So because a lack of the awareness or familiarity amongst the stakeholders would lead to refusal or the rejection of using this sustainable technology just because it's emerging and just because we're uncertain about it. So so a lot can be done to improve that on that aspect, to help to improve that. And one of the other benefit is social status. So if it has the effect of raising the social status of building owners who adopt this and promote this technology being green and in line with SDG. So and so a perception, so trying to say is that the perception towards BIPV technology can be a determinant factor when deciding whether the owner would want to invest or not, because maybe the social acceptance or the status that it can give the building owner. So so in this slide, I've just summarized. So Sajani did the slides and it's very beautiful. And so this is the chart that was produced by the frequencies in the literature. So based on the chart, the most frequent identified benefits were really social related. And for cost design, we find that design related had the most frequencies in the in the literature. Okay, so so in our discussion, majority of the literature has been strongly focusing on number crunching and of the energy and economic performance of the BIPV system, and that really helps to everyone to understand the benefits of using BIPV, and that's the intrinsic value. And we're trying to discuss the extrinsic value of the technology. So we should not overlook. Sorry, I'm listening to my echo.
Just to wrap up, just 1 minute more.
Okay, thank you. I'm at my end, sorry. So extrinsic value of the technology should not be overlooked when assessing the net benefits. And because it can help us in deciding whether to adopt or avoid the technology. So in conclusion, the study found the following factors that are really important, which is the lack of public awareness, limited stakeholders' knowledge, design complexities, the reliability of system. So it's essential to adopt, to develop a robust framework that will set out the path towards the attractiveness of the BIPV as a viable renewable energy option. So especially people in key positions, including policymakers, may help in doing so. So and we can improve on the building codes to help provide adequate technical information, and universities, tertiary institutes should help to enrich our curriculum courses dedicated to BIPV. Government bodies may make use of visual impacts and install the systems in various governmental buildings and CBD areas to increase the greater awareness and public acceptance by the society. And investigating and promoting these extrinsic values could become part of the best practice even for other sustainable technologies. So in terms of further research, we think that further research could be carried out to devise strategies to help address these barriers to implementation of BIPV. and also develop a comprehensive framework in the implementation at a national or state level, in line with our government's agreement to reduce carbon emission. With that, I thank you. Any questions? Thank you. Welcome.
Thank you. That was really interesting. Any questions from the people here or the online people? Okay, there's a question, interesting paper. Does the integration of PV panels on the building envelope or the fabric consider the effect on the building thermal performance of the envelope?
Yes, so the BIPV material, you can adjust the material to have varying thermal properties to match the thermal transmission that we require for the building. So in overall, yes.
Thank you very much. Any other questions? Thank you. This is really interesting technology, and I think it's really crucial that we work on the social awareness. Thank you. I think this concludes this session. Thank you very much.